Welcome to Lecture 7.4, Applications to Solving Linear System of Equation. I'm going to run through a blueprint on how to solve systems of equations really quickly, and then we'll get into some examples. For step one, of course, you need to read the problem, and then you want to mentally list the items that are known and the items that are unknown. Because it is a system of equations, we're going to generally have two unknowns. And for the second step, we're usually going to assign those variables, maybe let x be one of the unknown items and y be the other unknown items. Then we're going to translate all the other information into expressions involving our two variables. The third step is we're going to reread the problem and then write out our system of equations using our items and variables that we found in step 1 and step 2 that describe our situation. Number 4, we're going to solve the system. So we're going to definitely get an answer for x and an answer for y. Depending on what method you use will be determined by what type of system that you have. Sometimes it's easier to graph it, sometimes it's easier to use elimination, and sometimes it's easier to use substitution. But you will use one of those methods to solve for your system. And then you want to write your answer in sentence, so you make sure that you have answered the problem correctly. And step 6 is you want to reread the problem, check your solution with the original words to the problem. This gives you an opportunity to analyze what solution you came up with against the original problem. And you should use your intuition to see if that makes sense. For example, if we solve this and we end up, we're looking for length of, I don't know, length of the leg of a triangle, and we come up with a negative number, well, length shouldn't be negative, so we should reconsider redoing our problem to make sure that our solution fits appropriately. Let's work through a problem step by step. So each one of the 6 steps. One number is 2 more than 5 times another. Their sum is 20. Find the numbers. So here's what we know. We know that 2 numbers have the sum of 20. We know one number is 2 more than 5 times the other. Here's what we don't know. The numbers. I know it's not exciting, but this is everything that we know and everything that we don't know. Step 2. I'm going to select x for one number. And therefore I'm going to choose y for the other number, which is, by definition, 2 more than 5 times the number. And if it's 2 more than 5 times the number, then that makes y equal 5x plus 2. One number is x. Wherever we see number, it's going to be an x. So 5 times, that's multiplication, x. 2 more is addition. Their sum is 20. Well, x plus y equals 20. Step 3 is to build the system. Well, I do have 2 equations that I've already built in step 2, but now I'm going to turn it into a system. X plus y equals 20, and y equals 5x plus 2. I'm going to solve the system. Depending on what information we're given, might lead towards using a specific method. Since I already know what y is, the easiest method to solving is substitution, in my opinion. So wherever I say y, I'm going to plug in 5x plus 2. That gives me x plus 5x plus 2 equals 20. Combine like terms, I have 6x plus 2 equals 20. Subtract 2 from both sides, leaving me 6x equals 18. Divide each side by 6. That gives me x equals 3. Now that I know what x is, I can plug x back into one of my equations to solve for y. So I'm just going to go ahead and do the 5x plus 2. So 5 times 3 plus 2. 5 times 3 is 15 plus 2. So y equals 17. Step 5 is to write it in a sentence so we can kind of see what we're looking for. So step 5 would be, so 17 and 3 are the numbers we're looking for. Step 6 is to reword the original problem using the information we found. The number 17 is 2 more than 5 times 3, and the sum of 17 and 3 is 20. This is the time you want to analyze, does everything you just said make sense? It's not necessary that you need to write it out, but it is something that you need to go back to the original problem, evaluate the numbers or the solution you found to see if it makes sense. If it does, you're done. If not, then you may have made a mistake. Let's try another problem. This time Mr. Hicks had $15,000 to invest. He invested some amount of money at 6% and some amount of money at 7%. If he earns $980 in interest, how much did he invest in each rate? So I'm not going to run through each of the steps, but you want to figure out, okay, well, the two amounts that I don't know is what he invested in each rate. Here's what I do know. If I add up both my X value and my Y value, I will get the total amount of money that he invested. So X plus Y equals 15,000. And I know that at each interest rate, if I add that up, I get the 980 in interest. So here's my second equation. The 6% in decimal form, so 0.06x, will give me the amount of interest earned for at 6% for the amount of money that I invested at 6%. The amount of money I invested at 7% times 7% will give me the interest rate at 7%. I add those two up, I get 980. So let me go over that again. X, the two amounts are X and Y. X plus Y equals 15,000. 0.06 times X plus 0.07 Y will equal the 980 in interest. Now, depending on what you prefer to do, you can either use elimination or substitution here. I am going to go ahead and solve for X and use substitution. I find that that's the easiest for this value or this equation. I'm also going to do a trick thing. So first I'm going to distribute the 0.06 to 15,000, 0.06 to negative Y, and then I get 900 minus 0.6y plus 0.7y equals 980. And I was going to do a trick, but I don't need to really do that for this problem yet. So 900 plus 0.01 y equals 980. I'm going to subtract 900 from each side. I get 0.01 y equals 80. Now I'm going to divide by 0.1. That gives me y equals 8,000. So I know the amount I invested at 7% is 8,000. Now I just need to plug back in to one of my original equations to solve for x. Well, x plus y equals 15,000. Plug in 8,000 wherever I see a y. So x equals 7,000. So I know Mr. Hicks invested $7,000 at 6% and $8,000 at 7%. Now there's a second way of checking it. What I do want to see is how much interest do I earn at 6%? Well, 6% times 7,000 is 420. 7% of 8,000 is 560. If I add the two of them together, yes indeed, I get $980. So that's just one more check that I can do to make sure that this whole entire problem I've calculated correctly. So here's a problem I'd like you to work on your own and have it prepared for next class. So it's a coin problem. John has $1.70 all in dimes and nickels. He has a total of 22 coins. How many of each kind does he have? Think about this problem in the same way that we did Mr. Hicks' problem. I know that I have two types of coins and they add up to 22. So maybe it's X for dimes and Y for nickels, and then that adds up to 22. And then the amount, the value of a dime times the number of dimes, the value of a nickel times the number of nickels, is going to give you the total amount of money that you have. So you can take it from there, set up your system, solve for your variables, and turn that in the next class session. Another common problem to use systems of equation are mixture problems. So how much of a 20% alcohol solution and a 50% alcohol solution must we mix together to, number one, get 12 gallons of a 30% alcohol solution? You can think of this as an investment problem or a coin problem. But this time my values are going to be the gallons I add up and then the percentages of those gallons of alcohol. Here's what I mean. I know that kind of came out weird, so here's what I mean. Let's say I don't know how many gallons of the 20% solution I need, and I don't. So I'm going to call that X. And I don't know how many gallons of the 50% solution I need, so I'm going to call that Y. So, let me get down here. I do know the two solutions together will total 12 gallons. Well, that's X plus Y will equal 12. I do know that one solution is 20% alcohol and the rest is water, and the other solution is 50% alcohol and the rest is water. So here's what I'm going to do. 20% of the gallons, the first gallons, the X unknown gallons, is the alcohol. The other 80% I don't care about. That's just water. The other amount of gallons, 50%, is alcohol. Again, I don't care about the other 50%. That's water. So I have 20% of the gallons at 20% alcohol, and 0.50 times the number of gallons at the 50%. That should equal 30% of the 12 gallons. Okay, so 0.30 times 12. And that's rough, and it sounds really weird. But if you think about it like a coin problem, if I know I have so many quarters and so many pennies, and let's say I have, I don't know, 40 coins, then it's the amount of the value of the quarter and the number of quarters plus the value of a penny times the number of pennies will equal a dollar amount. Same type of situation, but this last piece is it's a 30% of 12 gallons because the other 70% is water, and we don't really care about it for this problem, at least not right now. Now that I have my system, you can look at that as a table as well. Okay. Now I'm going to solve for my values. So I'm going to just substitute what X is by solving the first equation, plug that into the second equation, and considering I'm working with decimals and I don't want to work with decimals, I'm going to multiply everybody by 10 so I can get whole numbers. So 0.2 times 10 is 2, 0.5 times 10 is 5, and 0.3 times 10 is 3. So I can eliminate those decimals. Now I'm going to treat this as a regular problem, distribute where I need to, add like terms where I need to, ultimately solve for my variable. So I'll let you look over this problem, but ultimately Y will equal 4 gallons. So I need 4 gallons of the 50% solution. Well, I still have to figure out how much I need of the 20% solution. Well, X plus Y equals 12. So solve for X, and X equals 8. So I know 8 gallons of the 20% solution and 4 gallons of the 50% solution will give me 12 gallons of 30% alcohol. That's it for this lecture. So until next time, be seeing you.